Good afternoon. It's been a while since I've done a Sudoku, but well, I look very pale. No, let's go. Cool. We're doing episode 6. Got no idea what it is. Thermometer Sudoku. Best time, 1 hour and 14 minutes. Oh no. Okay, let's understand the rules again. Knight, the same number cannot appear twice within a knight's move. Okay, that's chess. I can't remember if we've already had that. So this 6, obviously. All these are knight's moves, and the 6 cannot go in any of them. And thermometer. Numbers must increase as they move along the thermometers, starting at the bulb. So let's say this is a 1. This has to be, well, it can't be a 2 because of that 2. It has to be greater than a 1. Let's say this was a 7. This has to be greater than 7, so that has to be 8 and 9. So pretty simple to start with. Not many rules, but I mean, I reckon the quicker I start this, the better. So numbers must increase along. So this has to be a 1, 2, 3, 4, 5, 6. Obviously, that can't be 1, 2. It has to be at least. It can be 1, 3, 4, 5, 7, 8. Because obviously, a 6 can't go there. That can't be a 2, so this could be a 3, 4, 5, and that can't be a 6. So count the other way, so this can be a 9, this can be an 8, and this can be a 7. Because we can go, that doesn't have to be like consecutive, because we can go 1, 4, 5, 7, 8, 9, or whatever. Okay. This number can be a 1. I think this can be really anything. So it can be all the way up from 1 to 4. Which doesn't really help us. That can't be a 7. That can't be a 2. 4, 5, 6. Okay, so no, that can't be a 6. If that's a 6, then there's no place for a 6 to go under the box because of the knight's move. If that can't be a 6, this can't be 7. That can't be 8. And that can't be 9. Actually, if this can't be 6, that math doesn't actually work at all. That can't be 6. But this can still be 7. This can still be 8. And this can still be 9. That means that can't be a 5. And that can't be a 4. Which means a 1, 3 pair. Which means we know there has to be a 4 in one of these. Because 3, 4, 5, 6. What next? Is the question. 4, 3, 4, 5, 6, 7. So let's say 3, 4, 5, 7, 8, 9. So the 3 has to have the 9 at the end. And the 1 can have 1, 2, 3. 1 can have the other 3 here. So actually no. There's a 9 up there. Which is not really helping us for much at all though. Four, 5, 7, 8, 9. 4, 5. Four. What? No, this should be 3, 4, 5, 7, 8, 9. Yeah. Okay, this one is looking very difficult. What do we do? What is the next logical step? Looking at night moves, these potentially. That could be a shout. Okay. So we know both these two digits cannot both be the same number. Because otherwise that number cannot go in this box. This trio is very... Because let's say if this is 7, that has to be 7, 8, 9, which makes that the 3. This goes 5, 7, 8. I mean, it goes 5, 4, 3, 3, 1. Ah! So that's a knight's move. So wherever the 3 goes, the 3 cannot go on the other side. Right? Right, that makes sense. Okay, so if that's the 3, this would be 4, 5, 7, 8, 9. And this side we're going to go 1, 4, 5. And that means we would have these two would both be 5s. 3, 4, 5, and 1. Can't be a 3 now. 4, 5. Which means this can't be the 3. But this can be the 3, because that can be a 1, 2. 5, 7, 9. That can still be a 3 or 4. Okay, we actually got the puzzle started. Those can't be a 5. So 5 has to be there in that box, which makes that the 4. I guess we could set the same for the 3 in this box like that. So no, this is actually a 3, 5 pair. Can we do the same for 6s? Not really. Okay, these ones on the edge of boxes are quite powerful. Because they corner off quite a lot of the box. There's 4 here, plus this 4 over here. There's 4. We could use the 4 logic there. No, we can't use the 2 logic. Okay, the 3 can pretty much still go anywhere. Okay, the 8 can't go any of the other those. The 8 has to go there. So 9 and 7 have to go on the same 3 tiles up there. I'm not liking this. So the 2 in that middle row has to go in one of the 2 white squares there. 6 doesn't really help. Oh, that's handy. So we know these numbers has to either be a 2, a 3, or can we say this has to be a 4 and a 2? Can we do that? Because obviously it could still be a 5 and a 3, no? I'm going 5 and 3. Because obviously the 2 here have to be one of these 4 digits. We've got 3 on the 5 and the 8. Does that mean that we have a 2 and a 4? Probably some proof that means yes, but I am not doing that because I've got no idea. Oh, 8. Oh, 8 could still go here though. The 4, nothing helpful. We already got the 4 in this middle box. 1. 6 also can't go in the middle. 9 has those squares. 8 also has those squares. 7 also has those squares. So 9, 8, and 7 all cannot go in those 2. Which means the 2 that are left that can go in there are the 1 and the 6. This is now a 7, 8, 9 triple here. 6 obviously can't go there. That's quite handy actually. 6 doesn't give us much. Until we get a 1 up here somewhere. 6 do anything? Well, you got a 6 in that box, so not really. Okay, where to next is the next big question. Okay, we know 8 can't go there. Good if we could figure out what this was. Be really handy actually. We still know 2 has to go in one of those 2. What numbers? Okay, so we're missing a 7, 8, and 9, which let's say takes up these 3. The other number we're missing is a 1. In this middle row. Okay. And we don't really have any restrictions on the 1 whatsoever. Okay. Night thermometer must increase. Okay. What am I missing? Guess we could pencil like that as a 2. And a 3. And whatever goes there can't go in any of those, so this has to be either 7, 8, 9. And it's the same as this one, so let's just put a pink on it. No, those two are the same digit. Yeah, so we have been knowing this has to be a 2, 3, or 4, or 5. So actually no, this is 2, 3, 4, or 5. Same with this one, 2, 3, 4, or 5. It can't be the 3. Or the 2. So it's either 4 or 5. And this could still be all. Which is quite handy actually. Okay, I'm kind of a little bit stuck. Breeze. Let's just go by number 1. Cannot go in any of these squares. Which doesn't break at all. So we know that can't be a 3. Because that's a 3 can't go in one of those two. Next stop is Hokkaido. Guess we know that can't be a 6. Which doesn't help us one bit. Okay, this 9 and this 7 both take up those spots. Does it do anything? Oh, jeez, it's late, bro. It's actually not, it's like 10 o'clock. Okay, so in this row, we need a 2, an 8, and a 9. By my maths. Which are not compellingly trustworthy. This could still be all. So those can't be the same. What's this 2 situation? Okay, that's handy. So actually no, there's a 2 here, so one of those two. Okay. That doesn't help. Okay. I'm looking at the 4 on this line. Can't go there because of this one. Can't go there because there. Can't go there or there or there. And we're just left with another 2 spots where that number can go. Just so not cool, man. Okay. Alright, so we know that 5's down there. 7, if we know it's not up there. No, so that can't be a 5. Okay, well, we look like we are stuck. Let's look at these ones. No, we've already looked at extensively at the ones. 2s. Threes, okay. Maybe it's the 3s that we need to break through with. So, this whole time, right? This 3's been telling me that that can't be a 3. How long have I? 20 minutes? So probably 15 of these minutes. Yeah. That's a 5, and that's a 3. It's crazy what happens if you actually, like, follow the rules that are given to you. 5 up here doesn't actually help us. 5 in here doesn't really help us either. So conflict there and there, and a conflict there. We know that's a 3 there. 2. 3, 2, 8, 9, and 1 is the other digit in this box, which can go in any of those places. Just mark that. 2, 2, 8, 8, 3. And the 9. Can also go anywhere. So it tells us that this is not an 8, a 3, or a 1. Which doesn't help us in the slightest. Tells us nothing much about this though. 7 and 9, take up those. Okay. 8s can't go there, but it can still go there. So whatever goes there cannot go there. Ooh. 4. Or should there be something very simple as well? Maybe these 4s. 6s. Okay, where to? Sure, there's an 8 there, so this can't be an 8. But these hypotheticals 2s, so let's say that's a 2. We'll be looking at that. And wherever that 2 is then placed, this bottom box would be looking at that. Which then means that this top box would be looking at that. That would mean that. So the 2 would go in the white spaces. Here, here, and here. 2 can't go there. Okay, so let's say this is a 2. Can't go there or there. Which means a 2 has to be one in here, which means in this it can't go on the bottom one, can't go on the middle one, can't go on this one, and can't go on this one. Okay, so I marked it wrong, so the 2 has to go there then. Which means it can't go there, can't go there. It will be one of these 2, can't go. Can we prove something similar with that 2? No. Hmm. What to? Okay, this column. We are missing a 1, a 7, and an 8. Oh no, this can't be the 1. This can't be the 8. And that can't be the 7. So that's the 1. 7, 8 pairing here now. Which has to be a different colour to this. So that's a 7, that's an 8. That's a 9. And we know that can't be an 8, so that's the 7. That's the 8. 7 in this box has got to be solved now. Yep, so 7 has to go there. Okay, which removes 7 out of there. Doesn't extremely help us. No. 7. Doesn't help us much over there. There's 8. Yes. Yes. So 8 has to go here. So means 8 cannot go there. And this what left in that box is here. And the 9 now can't go there. So the 9 has to go to the top. One, 2, 7, 8, 9. Right. So like that on the pattern down there. So I know there's a 7 here. Means that cannot be a 7. There's a 7 over here. Nine, if that's an 8, that's a 6. That's a 8, that's a 9. Can we actually rule out? So 5 can't go there or there. 4 can't go there or there. 1, 2, 3, 4, 5, 6, 6 and 9. 9 can't go there, so 9 has to be here. 6. Anything special about those 9s? No. Okay, so down here we actually need a 5, a 6. Need a 5 and a 6 down here to fill out this row. Okay, this is starting to get a little annoying. Because we are close to getting this whole thing to break. What am I missing now? These ones haven't been useful whatsoever this entire game. Just we know that those can't be ones. Ain't that right? 2 can't go up here. So that's 7 9. The 9. Should we know that can't be a 9? Next 9 can go there. Oh, almost had it. Oh no, that can't be an 8. But that's given already. Okay, surely something I can do something here. Like, why is this just not doing anything for me? Okay. Let's go through the numbers again. 1. Nothing with 1, 2s. So we know these can't be 2s. No, there has to be a 3 there. Well, we know this can't be a 5 or a 6. Like we know whatever number goes here also goes up here. Because if let's say this is a 5, can't go there, can't go there, so okay, no, obviously can't go not higher than itself in the number line. So those two numbers are the same. Given we know that there has to be a 2 and a 3 on here, and this is neither 2 nor 3. This is our 2-3 pair, so this has to be the 2, this has to be the 3. Okay, 2 in this row here can't go there, can't go there, can't go there. Okay, nice little breakthrough. A 3. 4 can't go there, so 4 has to be up here. And it can't go there because it's be a 5 or 6. I hope that actually works logistically. Otherwise, this whole thing is down the bin. Fucking brother's FaceTiming you, man. I should probably respond, but I just got locked in, you know? You know what they're saying? Bros after Sudokus. Bros after Sudokus. Is that wrong? Oh, I've got no idea. Why is he FaceTiming me at 11:10 p.m.? It's a very good question. And then again, okay, we know that that one's not a 5, so that's the 5 in that box. Oh my god. Please tell me that this just makes all my problems go away. Not quite. this can still be a, so we'll know that this is 6 or 8 as well, though. Which means this cannot be an 8. Which we've got our another colour. Which means this and this have to be, that has to be an 8 now. Which means, okay, well the 8's removed, that to be a 6, that to be an 8, that to be a 9. That 9, 2 over here, 8 over here. 2's now only there. Now I think we have solved to that because the night rule. And this is the last spot for 2. The 9 has to go there in that third row. How do we get this 4? Oh yeah, because it had to be a 4 or a 5. The 5's up here. So this now has to be a 1 or a 7. Let's get rid of that colour because it means nothing. Now let's get rid of these 5 colours. Oh, we actually get this number as well. 1, 2, 3, 4, 5. Last one in that row. We get this because of that as well. 5 goes there. Not there though. Moves a 5 from there. 5 can't go there. Yes, the 5 now goes there in that box. And then we also have a 617 in there. Chooses 7 and 1s are getting a little bit annoying. This has to be either a 7, a 9, or a 6. Do I have anything that can't be? Not really, actually. Okay, these 8s, this 5's powerful. Eight in this box has to go up here now. Are we finished with the 8s? Not quite. Okay, we've got another article, these X-Winds of 8. Now that can't be a 7, because then 7 cannot go anywhere in this box. Once that's pink is now on 9s. That can't be a 7 because of nuts. Okay. Okay. 6s. Nothing. Okay. 1s. Can I do anything with my 1s? No. 2s. I completed. 3s. Can't go there. 3s I've got absolutely nothing for. 4s. There's another 4s there. Which puts a 4 in here. Just puts a 4 there. And there. And ends up back up there. Cool. 5s. Surprisingly, can't do anything with 6. 7. Goes in one of those 2. 8. Yeah, 8's that annoying little X-wing. 9. Can't go there. Which one goes there? And there. Goes that one moves. We have a 1 down here. So we have 1 over here. So this is 1, 7. 5. Now I can't guess. That's a 5 now. Twins, that's a 5. That's a 5. That's a... Nope, not a 7. An 8. It's an 8 there. We know that can't be a 6, otherwise 6 couldn't go there, so that's the 6 down here. Now this is now not a 1, it is a 1. 3 pairing. Which means this is the 6. And 1, this is now a 3. Okay, this is getting close to finishing. So this top row needs a 1, a 3, and a 6. And that can't be a 6. Which means this is also 1 through 6. It's 1 through 6, 7. That can't be a 6 or a 3 or a 1. So that's actually the 7. Crazy how that works, man. Now, how do I do this? The 1s. Oh, that can't be a 3 because of this natural, which should just break the puzzle. Not quite. Okay, and that can't be a 7, so that's also a 1. 3, 1, 6, 6, 3. Cool, 53 minutes. A bit shorter than my previous attempt that I did like 8 years ago. Annoying. But yeah, looks like I'm FaceTiming back my brother.